Okay, let's look at section 1.9 today. And 1.9 is all about multiple representations. This one you're going to see kind of a summary of what we have done up to today, including factoring, substitution, graphing, reading, no reading tables, so graphing. And just looking at this, it is a worksheet I wanted you to do together with a partner in class, but I'm going to walk through a few of them just to give you some guidance on it, or if you had questions after you finished, you can walk through with me. So on number 1, it's asking us to find the limit as x approaches -4 of f of x over g of x. So I'm just going to go up above and I find f of x and I find g of x. And I notice that g of x, which is on the bottom, will be discontinuous at -4 since -4 is not part of the domain. So I think what I want to do is approach it from a factoring technique. And the first function, f of x, will factor into x minus 7 and x plus 4. And then obviously we can see that x plus 4 will eliminate, and that leaves us with the x minus 7, and we can just plug in our -4 minus 7 and come up with -11. So factoring will work on number 1. Factoring will help you on number 2, but it doesn't solve the problem. It just gives us a little bit more insight. So on number 2, when I do that factoring, g of x is sitting on top this time. So I have x plus 4 over x minus 7, x plus 4. And be sure you're always writing the limit over and over and over, because that is the actual problem. It isn't simplifying the rational. That's only part of the technique used to solve the limit. All right, so I end up with 1 over x minus 7. 7 is not a domain value, and I would get a 0 on the bottom. Now, what I don't know is, does it both go to infinity from the left and the right, or does it do one of each? So I would go ahead and investigate this a little further. So I'm going to go the limit as x approaches 7 from the left side of 1 over x minus 7. From the left side, that would be like 6.9. So I have 1 over 6.9 minus 7. I'd have 1 over a negative, a very small negative, which will lead me to negative infinity. Now let's go investigate the other side. So I'm going to choose right here to work. The limit as x approaches 7 from the right side, so a little bit larger than 7, I'd have 1 over x minus 7 is my function. And if I put something a little bit bigger than 7 and I subtract 7, I'm going to get 1 over a very small positive. And 1 divided by very small positive would equal positive infinity. Now I take a look at it and compare my two results from the left and the right of 7, and I notice that they are not equal. The limits will have to, or do not match. So for number 2, I will have to answer that the limit does not exist. I was hoping to give a little bit more information, like it goes to infinity or it goes to negative infinity, but one branch goes one way and one branch of the function goes the other way. So D and E on this one. Number 3 has the absolute value in it. They want us to compare the g of x function divided by h of x. And we're only coming from a one-sided limit, so we're coming in from the right side of -4. And let's just sketch this out. I'd have the limit as x approaches -4 from the right. G of x is x plus 4. And then I have a -2, absolute value, x plus 4. Well, x plus 4 over x plus 4 would cancel to 1. The only thing I need to really think about is, how does the absolute value impact this? If I'm coming into -4 from the right-hand side, it'll be larger than -4, so it'd be like -3.9. So I would have like on top, this could look like -3.9 plus 4, and on the bottom I'd have absolute value of -3.9 plus 4. Well, those are going to be the same value. In this case, it would be 0.1 over 0.1, which reduces to 1. And that's going to be the case, is this will always turn out to be a positive quantity. So therefore, the absolute values really are not essential. So I could think of this really just as parentheses, since I'm going to be a little bit larger than -4. And if I have parentheses around this, then this really does eliminate, and I have -1/2 as my result. Let's go over to the right-hand corner, upper right, and we have 4 problems there. Given the function, the graph of the function f of x, there is a vertical asymptote. I think I'm going to draw in my vertical asymptote at x equals 6, just as an easy reminder. Okay, so as we approach 2, what is the limit? As I approach 2, I don't want to fall for the point. I want to fall where is the graph approaching left and right, and that would be equal to -2. For number 2, we approach -1. The limit from both sides, well, I come into 1 from the right to -2 from the left. This would have to be a DNE. Number 3, -1 from the left side, -1 from the left side. Left side is over here, so I'm coming in from this side. It looks like we'd have -2 and 6. 6 is a little tricky because we have that discontinuity going on. I would analyze and show my analysis. I'm going to look at 6 from the left, and I'm going to show analysis on 6 from the right of f of x. Make sure you make a complete mathematical statement there. So a limit needs something to perform its operation on. And that was f of x. So 6 from the left. 6 from the left means I'm going to positive infinity. 6 from the right means I'm going to negative infinity. These two do not agree. Therefore, I would have to answer D and E. Alrighty. Down in the left-hand corner, they want you to sketch a graph of that. So I'm going to just sketch one possibility. Now yours could turn out to be different. This is a given. That's just a point, and the point is at 1, 0. From the left side of 1, I have to approach 2. So I want to come in here. It's going to be an open circle. I'm just going to come in with some sort of linear function. And then from the right side of 1, I should be approaching -1. That would be an open circle at -1. And once again, I'm just going to do a linear function. Number 2 has a little bit more going on. My function was going to, I have an asymptote at 2, because from the left and the right it approaches infinity and negative infinity. That is the definition of a vertical asymptote. So from the left side of 2, we are headed to negative infinity. So I know I'm coming down to there. From the right side of 2, I am headed to the positive infinity. And then it says here, as I approach negative infinity, I hit 2. That's a horizontal asymptote. And so I want to be, as I head out here to negative infinity, I'm going to be at a height of 2. And then I'm just going to do a nice connection here of those two. And then the other one, as I head to positive infinity out here, I should be reaching -2, so down in there. take off that tail a little bit, and my function should look like that. All of our functions should be pretty close on that one. We should agree on number 2. All right. For number 1, it says which of the right corner does not exist for the same reason as problem number 2 in the upper left-hand corner. I chose number 4 in the right-hand corner. And from the left corner, I chose number 2. They're both headed off to infinity, negative infinity. They are an asymptote occurring at their values that the limit approached. Sketch a graph of the limit described in the first problem in the upper left-hand corner. If you recall, that left-hand corner, that reduced down to the limit as x approaches negative 4, it reduced to x minus 7. And that function agrees with my original function at every spot except at negative 4. So I am going to have a linear function. It's going to graph as a linear function. 1, 2, 3, 4, 5, 6, 7. So there's negative 7. 1, 2, 3, 4, 5, 6, 7. There's positive 7. I have a linear function of x minus 7. But that's not all, because we had a hole described at negative 4. Yeah, we have a hole at negative 4. I need to keep on going here. So 1, 2, 3, 4, negative 4. Insert, open this up, and insert a hole. So it's a linear function with a hole at negative 4, because negative 4 is not in the domain for problem number 1. And then number 3, explain the difference between g of 1 and the limit of as we approach 1. Well, g of 1 is a point, and it looks like, what are we going? Using 1 from the bottom left corner. 1 from the bottom left. Looks like that point is at 1, 0. So this is an ordered pair. It was 1, 0. Whereas this, the limit, describes what the function is doing from the left and the right side of 1. And that left and right side of 1, they do definitely approach different values there too. So that gives you a quick review. If you had trouble with that worksheet, now you can fill in some of those gaps that maybe you had in solving all of that.